Okay, so class today we're going to look at properties of linear relations. For properties of linear relations, we kind of have two focuses. Number one, we want to see if it's linear. And number two, we want to see if it's a function. That's kind of what our focus will be. Now to do that, you kind of have to graph these things, okay? So keep in mind here, number one, you might have to find and graph points. So you might have to see your graph, okay? And so when you're doing this, you kind of want it like at least 5 points. If you're unsure of some things, okay? As well, then you're going to have to check the format. So does it fit into y equals mx plus b? Because if it does, then you can graph less points because you know how to graph those, okay? Then you also want to look and see if it does, you're in luck because then you have a constant rate of change. And if you have a constant rate of change, then guess what? It's linear. Okay? You got to watch out for two exceptions. Number one, you got to watch out for y equals something like 2 and x equals 3. And that's because these are special lines. So if you have an equation in that format, that's a little bit different than normal. Okay? So let's have a look here. Determine whether or not the following relations are linear. So here it's what fits y equals mx plus b. So it's linear because it fits the format. So I kind of worse my English here because it is y equals mx plus b. Okay. And what we're showing is that 5 is a constant rate of change. And we're going to see some where there isn't a constant rate of change. Okay. So for example, this next one here, we have xy equals 6. So y would then be 6 divided by x. Okay. So here it's not linear, because it is not y equals mx plus b. X is in your denominator. Okay? So if x is in your denominator, it's not going to be linear. Next one. C, does this fit y equals mx plus b? No. So this is not linear. And that's because it's not y equals mx plus b. Okay. What about D? Is D y equals mx plus b? Okay, well tell me what it is then. What's m? Okay. So move it to the other side. So we move 5x over, minus 5x. Move the negative 6 over to plus 6. Then the next step is we divide by 3. So negative 5 divided by 3x plus what? 6 divided by 3. What is 6 divided by 3? 2. Okay. And so it would be yes, linear. Because it's y equals mx plus b. Okay. Any questions so far? Okay, so next one. Does it look linear? How do you know? You don't. What you actually have to do you actually have to graph these. So make a quick little graph, okay? So I'm going to take my axes and I'm going to make an XY axis real quick. Not too difficult, not too big. Okay, and so I'm going to graph, looks like I'm going to 10 and 10, right? So 10 and 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so now I can graph negative 9, negative 10. That's going to be down here. Negative 7, negative 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Negative 5, 0. 1, 2, 3, 4, 5, 0. Oh, I'm totally messing this up. I gotta do a better graph. So you could just turn to one of your other graphs and draw it on there if you like. I'm just going to try and keep it all in the notes here. There we go. And so like that. There we go. 7 and 5. 1, 2. And negative 5 and 0. 1, 2, 3, 4, 5. There we go. Negative 3 and 5. 1, 2, 3, 4, 5. 1, 2, 3. Good. And negative 1 and 10. Okay, so you should be able to get a straight line. If you did it on graph paper, you would have got a straight line for sure. It's not letting me make a straight line, which is kind of weird. There we go. Okay, so it is linear. All right. And the other reason why you can see it's linear is we can look at our rate of change. Look at our m value. So what's our y's going up by? How do you go from negative 10 to negative 5? Go up negative 5 to 0, 0 to 5, 5 to 10. So our m values, we're going up by 5 each time. Okay. Our x values, what are we going up by? 2. So our slope is 5 over 2. So it's the other reason why it's linear is that there is a constant rate of change. Okay. Any questions? So 2 ways. Number 1, you can graph it. Number 2, you can look at your rate of change. If there's a constant rate of change, it is linear. Good. Number F, let's graph that. What does that one look like real quickly? X equals 6. 1, 2, 3, 4, 5, 6. There we go. X equals 6. Is that a straight line? Yeah, this one is linear. It's a special line, but it is linear. Okay. Good. What about this next one? So this next one, let's just copy down the chart, okay? So what we have here on the chart, this will be your time in years. And then we have the value of the painting. Okay. So, time zero, at the very beginning, this painting is worth $10,000. After 1 year, it's worth $10,800. Then the second year, it's worth $11,664. Then year 3, it's worth $1,259,712. Okay. The reason why is because it's going up by a percentage based on what it was the previous year. Okay, so it's not going up by a constant amount. What you're going to notice is that in between, here goes up by 800, here it goes up by a heck of a lot more, and here it goes up by a heck of a lot more. Okay, so let's have a look here at the math. You guys got the chart copied down? Okay, so 8%, just to let you know, 8% basically means that at the end of the year, the painting's worth 108%, right? It's worth the increase plus what it started with, plus the 100, the full amount, okay? So for year 1, it'd be 10,000 times 1.08. So it's worth $10,800. Okay. Then for year 2, okay, so that's an increase of 800. For year 2, then it's going to be 10,800 times the percentage. So now it goes up by a heck of a lot more. Just ignore that part. So then again, now you're going to take 108% of 11,664. So I take the percentage of an even larger number. Okay. So we're always taking the percentage of a number that's larger than the previous year. So it's not going to be linear, because it's not going up by the same amount each year. Okay. So what we say is this is appreciation. Appreciation and depreciation are not linear. If you graph that, you would have what we call exponential growth and decay. Okay. So just note that appreciation and depreciation are not linear. Just like when you buy a car, its value decreases really fast as soon as you drive it off the lot, and then over time it gets less and less. Okay. So real quickly here, this is what our graph looks like, okay, of the painting. This is appreciation, where your value starts off small and then gets larger and larger. And of course, as soon as the artist dies, then it gets even more expensive, increases by a larger amount. Whereas this next one, okay, brand new car, about $30,000. That's a little dated. Now it's probably like $40,000. And all of a sudden, boom, it just drops in price right away. And then eventually, it kind of bottoms out. This is like the used price of a car. It'll still go down a little bit, but on average, when you're looking to buy a car, a used older car, about $1,000, right? That's kind of the value of a car. If you're looking at like a Toyota Corolla, probably like a 2010 Toyota Corolla, it's about $1,000 to $2,000, depending on how good a quality it is. The insurance will be about $4,000 or $5,000. The insurance is going to be way more than the car. Okay, but the car's value is usually about that. Okay. All right. Any questions? All right, so next one here. So for H, if you're just given the points, look at your rate of change, see if it's constant. Here we're going up by ones. What are we going up by here? 3. Then what are we going up by? Then what are we going up by? 5. So it's not linear. So your slope equals, don't know. It is not constant rate of change. So it is not linear. Okay. So you could also graph, right? You could graph it and see it as well. Okay, if you're unsure about that. All right. Any questions? I have a question for you. How come I can't see my taskbar and see if Snagit is actually recording this? That concerns me. Oh well, whatever. So next part is it a function? Okay, so is it a function? What do you guys think about appreciation, depreciation? Is that a function? Well, it is a function because pass the vertical line test. You can draw a vertical line anywhere and it won't have 2 data points, so it is a function. Okay. Let's go looking back up at the top ones here. Are these functions? Is that a function? Yes, it is a function. Okay, because if you graphed it real quickly, here's +1, and then your slope, you go up 5 over 1. That's what the graph looks like. So it is a function. Okay. So if it has some slope, if it has a slope, then is a function. Looking at the next one, is it a function? Well, this one graphs like this, graphs like that, okay? And that is a function then. So if you do an XY table, that's what you'd notice, okay? Next one. This one is a function. So if you do an XY table, x is 2, 2 minus 1 is 1, 1 squared is 1, x is 1, then we get 0, x is -2, then you get, -1. Substitute in, you get 4, x is -2, you get 9. So when you have the squared, these are called parabolas. So it's going to be something like that, okay? But, so it's not linear, but it is a function. And it passes the VLT. So going back to the good old vertical line test, okay? The next one, is it a function? So graph it real quickly. Here's +2. A -5 is down 5, right 3. Boom. Is it a function? Yes, it's a function. Okay. This one, we graphed it. Passes the VLT, so it is a function. You could put passes the VLT for all of these, by the way. Next one, is it a function? No, it's not a function. Okay, it fails the VLT. It is a vertical line. Okay, totally fails the VLT. That's the only one that does. Okay. Unless you get into some circles and some other funky junk. All right. Any questions? Okay. Once you got copy, oh, the last one here, if you graphed it, what you'd see is this. You would see it going up like that. Is that a function? Yeah, it's not linear, but it is a function because it passes the VLT, the vertical line test. Okay. All right, there we go. Next one. So interpreting graphs, looking at rates of change. Remember with your rates of change, okay, it's going to be rise over run, which is your y over your x. And what you got to make sure for this one is you got to include units over units, because then you get some special ones like kilometers over hours, right? So that one would be kilometers per hour, which is speed, okay? Rates of change equals your slope. So they're the same thing. Usually call rates of change when we start talking about graphing real situations. So here we have a graph of a radio-controlled airplane. It is the height in meters versus time in minutes. Okay, so what does the slope represent? So for this one, your slope would be your height over time. And what are the units then? So your height would be meters and your time would be minutes. So if you wrote it sideways, it'd be meters per minute. And isn't that kind of like kilometers per hour, except the units are different? So this one here would be speed, but this is talking about going up or down, so this is actually would be your vertical speed of how fast the plane is going up and down, okay? But we look at our units to help us try and identify something like that. So what's the rate of change between B and C? Right here, between B and C. So what is your rise? Rise over run. Your rise is 0, your run is 2 minutes. Okay. So what does that equal? 0 meters per minute. Okay. So between B and C right here, what does 0 meters per minute mean? What's happening with the plane? Is the plane flying? Yeah. How high is the plane in the air? 6 meters. Is it going up or going down? It's staying the same. Okay, so the 0 meters per minute means it's not going up or down. It's staying at the same height as it's flying around. Okay, so you got to visualize the information based on the graph, based on the numbers. Good, so between C and D now, okay. So what's here between C and D? Between C and D, we got to find this slope. What is your rise? -2. What's your run? 1, 2, 3, 4. Okay, so the rate of change between B and C would be -2 over 4, which is -1/2. Okay, and that would be meters per minute. So what does the negative rate mean? What's happening with the plane? Here? Yeah, it's going down, right? So the negative rate means that the plane is descending or decreasing in height. Decreasing. Okay. So that's what the negative slope means. Good. What's the average vertical speed between A and D? So between A and D, what's the slope? Well, M would be your rise over your run. And so your rise is 1, 2, 3, 4, and your run is 9. And that would again be meters over minutes. So that equals 4 over 9 meters per minute. Okay. And so that's the average vertical speed. So you are going up. So what's the, what's that? You're going up. Yeah, so you're starting on the ground, and then it's rising that far. So it's just our average. Okay, it's just our average. All right. Calculate the vertical speed between the plane's first ascent to its maximum height and then its final descent. So the first ascent is going to be between A and B. Okay, so the slope between A and B is what? What's our rise between A and B? 1, 2, 3, 4, 5, 6. So between A and B would be 6 over what? 3. So that would be 2 meters per minute. Okay. So don't forget your units as well. Okay. So then that's how fast it's going up. Because remember, planes on takeoff, they climb really fast, right? So that's, but what about going down? Going down, you don't want it to go too fast. So here, what's our vertical speed between E and F? So M, E, and F. What's our slope between E and F? 1, 2, 3, 4, 5, 6. Okay, so it'll be 6 over how many minutes? 2. So it'll be 3 meters per minute. Okay. And that would be -3. Okay. So we're going -6, -3. Okay. So to find the change or the difference, you're going to have to ignore the negative sign. Because the negative sign here is just going to tell us the direction that the change is occurring. It's going to tell us whether we're going up or down. So ignore the negative sign, and the difference is 1 meter per minute. Okay, so it's descending 1 meter per minute faster. We got to ignore the negative sign because the negative sign is just telling us whether we're going up or down. And that's a little bit of a weird part. All right. Any questions? Next one. A slow pitch team is hosting a banquet. The caterer charges a setup fee of $500, and it's $5 a person. So a setup fee, that's usually our code for a constant. Okay, and the $5 per person is our rate of change. Which is also our slope, which is our M value. Okay. So what we're looking at is we're looking at two things. We're looking at cost, and we're looking at number of people. So we have to do a depends on sentence to figure out which ones are dependent and independent variable. So does the number of people attending the banquet depend on the cost? The number of people attending the banquet depend on the cost. Let's turn it around first. Does the cost depend on the number of people that attend the banquet? See how one of them is kind of like, well, maybe, but the other one's a yes, it is. That's why you got to always try both. Okay? Yeah, so cost of the total cost of the banquet depends on the number of people that attend. And that's true for any event that you have. So what that means is that cost is the dependent variable, and the independent variable is the number of people that attend. Okay? So to write this as a linear relation, well, we would say y equals mx plus b. And what is your y value? What is your independent, so what's your dependent value? The cost. Equals $5 times the number of people, oops, plus the setup fee. That's going to be your total cost to put on this banquet. So instead of writing the word cost, we will say C. M will be $5 per person, so 5 times P. And the setup fee never changes. It's $500. It'll always be the same if 50 people attend or 5,000 people attend. Okay. So what's the rate of change? It is $5, and it is the cost per person. Okay. So it's like the cost of the meal, right? It's $5. Now, an actual cater, do you guys know what an actual cater usually costs? Any ideas? Well, probably about $20 a person, usually, something like that. Right? So when you have like a wedding and stuff like that, it can be anywhere, I think from 15 to 30 is kind of common. Depends on what it is, etc., etc. Okay. So now that we have an equation, what will be the cost if we have 325 people attending? So we would say P equals 325. We can use our equation. So 5 times 325 plus 500. And so a lot of you, when you have a wedding or whatever, you're going to calculate this out. You might not make an equation, but you're going to figure this out. Yeah, I know how much this stuff's going to cost you, right? Weddings are expensive. So you go to your calculator. What is it? Who's got it? 1,625, do you agree? 1,625? Oh, you'd have the 500? Okay, 2,125. So the cost is $2,125. Good. So that's why we teach this, so that you can figure out how much it's going to cost to put on your wedding. Okay. Now here's another tip. Any questions so far? So the first one, you're reading your graph, interpreting your slope, what it means. Here, you're figuring out your dependent variable, independent variable, coming up with the equation, and using your equation. Now we're going to look at our graph and our domain and range. Okay. So identify your domain and range. This graph represents the volume of water being drunk from a glass changes with time. Now time is always going to be our domain. So this will be time. And it will be in seconds. So we've got to put S, the letter S, in brackets. Hayden, let's go, man. Okay. So your domain is going to be time. And it equals 0 to 12. Okay. Sorry, let's just say domain is time. What is our range? Our range will be volume. Okay. And it will be in milliliters. What is the rate of change and what does it represent? So here, it would be volume over time. The maximum volume is 600. So now we're going to make our triangle. These graphs are nice because your triangle is kind of done for you, isn't it? Right? Volume is 600 and time is 12 seconds. And so 600 divided by 12, oh, it is negative 600. Okay. And it's negative 50 milliliters per second. What does that represent? Negative 50 milliliters per second. Yeah. Right? So what does a negative sign mean? Volume's going down. Where is this volume going? Yeah, into the dude's mouth, right? Because he's drinking it. So you got to understand what's being graphed. Okay, so what it means is that he is drinking 50 milliliters each second. Okay, and the negative sign represents the drinking part. The part that's telling us the volume is leaving the glass. Okay? All right. What's the axis intercepts and what do they represent? So your y-axis, that is 600. What does that 600 milliliters represent? Yeah, the amount of water when? Sorry? At the start, right? Right? Amount of water at the start, or in the glass at the start. Okay, what about the x-intercept down here? What is that? 12 seconds, and what does that represent? The time to drink the water. Okay. So write an equation, y equals mx plus b. We found our slope, negative 50, and our y-intercept is 600. There we go. Okay, so now we have an equation and we have a function representing this situation.